Bismillahirrahmanirrahim. Let's start our class. In the previous class, we have discussed impedance relay or the distance relay, and then we have discussed the individual overreach solutions of the impedance relay. So now let us continue our discussion with the quantities to be fed to the distance relay. So as I told you earlier that there are many two types of distance relay. One is known as the phase distance relay, and the other is known as ground distance relay. Now we consider the phase distance relay and ground distance relay. Relay has to measure some value of the impedance. So whenever the relay measures the impedance, that impedance is known as measured value of the impedance that is measured by the distance relay. Now, whenever we consider the phase distance relay and whenever we consider the distance relay, each and every time, whatever quantity we fed, uh, whether it is ground relay or the phase distance relay, whenever we fed the quantities to the relay, because whenever as I have told you that a relay is connected somewhere on the secondary side, and we are uh, connected the input to the PT secondary. So relay will receive three currents and three voltages. Okay. So this three currents, that is for red, yellow, blue. Okay. Three currents. Okay. For red, yellow, and blue, and three voltages for each phase. Okay, so this is the bus, this is the transmission line, and CT and PT. CT for uh, feeding the current, and for measurement of the current, and VT for measurement of the voltage. Okay, so it receives three currents and three voltages. So whenever we talk about either phase relay or the ground distance relay, it has to measure only the positive sequence impedance from relaying point to the fault point. Okay, so what value we give means, value means that the value of the current and the value of voltage. Okay, uh, this is not I, this is actually V. So three current and three voltages. Okay, so these values must be given to the distance relay, so that for each and every type of fault, it measures the correct values, of the impedance from relaying point to the fault point. So our next discussion that is related to what value or what quantity we fed or provide to the distance relay. Obviously, quantity means voltage and the current, such that it always measures the positive sequence impedance, or the correct value of the impedance from relaying point to the fault point. So let us start our discussion with one by one each type of fault. Okay. So okay, so total 6 units are required to protect one single circuit transmission line at a particular bus. So with this background, let us solve one example. So here the 220 kV line is given. The impedance of this line is given as 2.5 plus J6. Okay, So this is the voltage of the transmission line, and impedance is 2.5 plus J6. So you can convert into the polar. And this line is protected by the relay R. Okay, this line is protected by the relay R. R is the which type of relay? This is the distance relay. So now this relay R is a reactance relay. It can be ohm relay or angle impedance relay. Okay, or it can be Moho relay. So three characteristics are available for the distance relay R. So we have to draw the relay characteristics on RX plane. Okay, we have discussed RX plane earlier. The CT ratio is given as 1000 by 1. This is CT ratio 1000 by 1, and the PT ratio is given as 220 kV by 110. Okay, 220 kV by 110. This is the PT ratio given in the example. And one more thing, all these relays means all type of relay characteristic, reactance, ohm and Moho. The relay has to operate in its first zone, which covers the 80% of the line section. So with this background, let us solve the example. Okay, so the line impedance that is given as the 2.5 plus J6 ohm as given. So if I convert this value in polar form, that then it comes out to be 6.5 at an angle of 67.38 degree. This is in ohm. Okay, this is ZL value. Now, as it is given that the first zone of the relay of any type of the characteristic that covers 80%. So, if I take 80% of this value, then we have the first zone impedance ZL, the first zone impedance ZL, first uh, first zone that is equal to what 80% of this. So this is 2 ohm plus J, which is 80% of 80% of this value, that is 4.8 ohm. Okay, 80%. Okay, all these relay, as it is given that all these relays are set to operate in their first zone, which covers how much percent? 80%. Okay, so the 80% of this is 4.8 ohm. Okay, so we have the value 80% of this is equal to 2.5 plus J6. So now 80% that is in the first zone. So ZL first zone is equal to 2 plus J 4.8 ohm. This is the 80% of the whole zone. So we have the impedance in the first zone. So now let us draw the characteristics of the relay. Okay, so move on. First, we will consider the characteristics of the reactance relay. The value is 2 plus J 4.8. Okay, the reactance relay. Okay, so let's move on to the characteristics. So I just take the value of the first zone, just write down it is 2 plus J 4.8. Okay, first ZL first zone is equal to 2 plus J 4.8 ohm. Okay, and this is the RX plane. Okay, and ZL M. So if I take the reactance relay, then as I have told you earlier that reactance relay has the property to measure what value? Measure the reactance of the line. Okay. So reactance relay measures the reactance of the line. So reactance of the line is 4.8 ohm. Okay. This is the resistance. 2 is the resistance and reactance value is 4.8. So the reactance, we are going to draw the characteristic for the reactance relay first. So reactance relay has the property to measure the reactance of the relay. So which is equal to 4.8. Okay. So whenever I draw the characteristic, then I have to draw uh, the characteristic of this just like R and X. So this point is nothing but your 4.8 ohm. Okay, R is your 4.8 ohm. R explains. So for X value is, sorry, the X value is 4.8 ohm. Okay, this is the X 4.8. From this is 0 0. This is 4.8 ohm. Okay. So any value below this reactance, wherever will give trade. Okay, so below this we will have a trip region, and any value above this relay point, we have the block region. Okay, so the measured impedance reactance is less than 4.8 ohm, relay will operate. Okay, if xm is less than 4.8, so the relay will operate, mean in this region. Okay, and if the value measured the reactance is greater than 4.8, then the relay will definitely be in the block region. Okay, so we have already discussed these two regions in the actual class. Now the second point is regarding the Ohm relay. Okay, so we have draw the characteristics for the reactance relay now for the Ohm relay. So for the Ohm relay, as we have already discussed in the earlier classes, that Ohm relay is the angle of the admittance relay. Okay, so we have to draw a tangent line with this line. So if I just tell you, if I take the angle which is 67.38, as we have converted it into polar. So in the polar we have the angle is 67.38. Okay, so using this angle value, uh, so the line to be protected, that has to be drawn from here, this region. Okay, this value and this angle will be just like this. Okay, move on to the next slide. So you will remote here. Okay, this is, so the line is starting from this. This is bus A and bus B. This is the whole transmission line. So the line will be drawn at the angle 67.38. So this is the line to be protected. That has to be drawn from here till this angle. Okay, which is 67.38 degree. Okay. This is the bus A and this is your bus B. So whenever you draw an angle from this point, which is 90 degree, okay, from this point, okay, so you have to draw the 90 degree. Okay, so move on to next slide. So you will see that I have drawn a line uh, which forming the 90-degree with this transmission line. Okay. Okay. So then this characteristics is known as Ohm characteristics or angle admittance characteristics. So now, then what will be the trip region and the block region for this Ohm relay? Below this line, uh, when xm is less than 4.8, okay, so then it will operate and it will be in the trip region. And when xm is greater than the measured xm means the measured reactance is greater than 4.8, then it will be blocked. Okay, so below this line, the relay will trip, or any value on this side, the upper side, relay will be blocked. Okay, so this was all about the Ohm relay. Now let us see the third point, that is the Moho relay. Okay, so as we have discussed, the Moho relay is a relay having a circular characteristics. So you can see this circular characteristics actually belongs to the Moho relay. Okay, so what will be the radius of the Moho relay? The radius of the Moho relay that can be calculated by, if I consider the Moho uh, value. Okay, so then Moho is equal to 1 square plus 2.4 square whole square root. Okay, so 2.6. Okay, so the let's draw the circular path for the Moho relay. Okay, this is the circular path, and it will be at 80%. Okay, the 80%, and the angle will be 67.3 degree. Okay, this angle is 67.3 degree. So Moho relay that is given by the square root of the half of this value, square root of the half of value. Okay, uh, 2. So 2, half of 2 is 1. Okay, and half of 4.8 is 2.4. So half of square root of the square of the half of this value and square of this. So you will get 2.6. Okay, the values come out to 0.6. That would be the circle of this relay. Okay, what is the point? The point is here 1 and 2.4. Okay, this is actually 1 comma 2.4, this line. Okay, so this is how the Moho relay works, and we can draw the characteristics of the Moho relay by this one. Okay, so this is actually uh, 1, this is 1 comma 2.4. Okay, in the Rx then R is the one value, okay, and X is 2.4. So this is actually the you can see uh, this the whole diameter of this form over there. Okay, so we have discussed this and we have drawn the characteristics of all the three types of the relay, that is Ohm, reactance relay, and Moho relay. So in this class we have discussed the quantities to be fed to the distance relay, and Then we have seen that for a phase relays and the ground relays, we have to give different voltages and the currents quantities, and then the relay is capable to measure correct value of the impedance. Okay, and at the last we have discussed a numerical example. So I have to stop here. In the next class, we will discuss the transformer protection. Okay, so the transformer protection. No, in this class, we are going to discuss the transformer protection. Okay, so let's start our discussion about transformer protection. Okay, so we know that the faults are inevitable, and if you see transformers are one of the equipment that are majorly used in the whole grid station. So there are these are facing different type of faults that may occur in the transformer. So these faults are categorized by the first, that is known as incipient fault. Okay, so this is the incipient fault. This is the first one. Incipient fault are also known as the minor faults. Okay, so we will discuss these in detail. Okay, and then uh, okay, so incipient fault are usually not occur inside the winding or the core of the transformer. Okay, so that is why these faults are known as incipient fault or the minor faults. Okay, so the second type of the second type of the fault that is known as the internal fault, and these are also called as electrical faults. Okay, the second one, which occurs these type of faults occurs in the winding and the core of the transformer. Okay, and the third type of the fault that is known as the external fault, and this type of fault occurs outside the transformer, and this fault are not a part of the transformer itself. Okay, so these three are the faults. Now let us start our discussion with the first type, that is the incipient faults. Okay, so as I have told you earlier, the incipient faults are also known as the minor faults. So what does it mean? It means we wish to detect this fault. We have to use the separate device in order to detect these type of faults. And whenever such type of fault is detected, that is there is no hurry that we have to trip the transformer immediately. But if this type of fault persists for a long period of time or longer duration, then this type of fault may be converted into the actual electrical fault, or you can say the internal fault of the transformer. Okay, so there is a need to be detected such type of fault immediately. So let us see what are the reasons behind the reasons because of which incipient fault may occur in the transformer. Okay, so let's discuss these one by one. So the first reason that is known as the leakage of oil. Okay, so we know that due to leakage of oil in the transformer, the oil level that may drop, and in worse condition, the bushings and the other part of the winding uh, they may expose to the air. So this increases the winding temperature, and which in turns finally damage the insulation of the winding. So how to detect these leakage of oil? So to detect a leakage of oil level indicator is used in the conservator tank of the transformer. and this type of abnormality can be easily detected. So the second reason uh, is the deterioration of the quantity of oil. Okay, this is the second reason. So we know that the transformer has two tanks. One is the main tank itself, and the second is called the conservator tank. So the oil tank or the main tank of the transformer is completely filled, whereas the conservator tank of the transformer is half filled. The reason for half fill of the conservator is to allow the change of the oil level because of the change in load. So the conservator tank expects the air via breather so that moisture cannot enter into the oil, because if moisture enter into the oil, then the dielectric strength of the oil will be reduced. So breather contains basically two things, the oil cup and the silica gel. You may observe this silica gel, which is a bluish type in color. So when with the passage of time, as it absorbs the moisture, the color of this silica gel is changed. So this is the indication of the changing of the silica gel. When the color is changed, so it must be replaced. Okay. So silica gel absorb the moisture that can be easily cleaned at two stage. First from the oil cup itself, and the second is the silica gel. So whenever we do the regular maintenance, we have also check the silica gel, as I have told you earlier, and we have to carry out regular cleaning of the silica gel. Okay, it is required to change it also on after some period of time. Okay, so that was it. The second reason, decrease of the quantity of iron. Okay, now the third reason for the occurrence of the incipient fault in the transformer, that is the failure of cooling system. So we know that we are talking about the power transformers. Okay, these are not the small transformers, but the heavy EHV and HV transformers. So the power transformers are very large transformers, and so the oil that is normally used for cooling, so because of the oil and winding temperature is reduced. Okay, so when the temperature increases due to the failure of the cooling system, so uh, it may be occur because of the failure of the oil pump, or maybe failure of some fan used in the transformer, or the blockage in the radiator. Okay, so these three may be the reason of the increasing of the oil temperature. So to detect this type of abnormality, oil temperature indicator and winding temperature uh, must be installed inside the transformer, which detect the temperature of the oil. Okay. Okay. So the fourth reason for the occurrence of the incipient fault is the transformer, that is nothing but the interturn fault, or the body interturn faults. Okay. So whenever the few turns of one phase or the multiple phases are shorted together, so what happens? Uh, then there are a fair chances of increase in the temperature because of the local heating. Okay, so in the worst case, this may transfer into the major fault, and we need to detect such type of fault. So keep in mind interturn fault that occurs or happens in the particular one phase or the multiple phases. So whatever protective device we use, normally differential protection that is not capable to detect such type of interturn or turn-to-turn fault. So we have to detect this type of fault with separate device or separate arrangement. Okay. So now let us see how to detect the such type of incipient fault that occur in the transformer. Okay. So we know that whenever such type of incipient fault occur, maybe because of the interturn fault or leakage of oil or maybe some other reason, then this type of fault produces heat. Okay. So this heat that is going to decompose the oil into the cases, and these cases are inflammable in nature, so which may create hazards. So this type of condition need to be detected on time. So in actual or real field, this type of incipient fault or condition that can be detected by the case operated relays. Okay. So let us discuss now the working of the gas operated relays. So there are two type of gas operated relays. Okay, which two type? One is the Buckles relay, and the second is known as sudden pressure relay. Okay, so the Buckles relay is the relay which is normally connected between the pipe connected between the conservator tank and the main tank of the transformer. So this type of devices are utilized particularly in our country. So whereas the sudden pressure relays are not connected between the conservator tank and the main transformer tank. Hence, it is used in some other countries. Okay. So now let us discuss what is the uh, working principle of Buckles relay. So the Buckles relay consists of the oil tight container, and this oil tight container uh, having two internal floats. Okay, oil tight container having two internal floats, and these two floats are provided and finally actuate the mercury switches below each float. The mercury switches provided. Okay, so there are two floats. Okay, the one float is known as the upper flow float, and the other float that is known as the lower float. Okay, so the relay that is full of oil and the floats remain engaged in their seat due to the U and C effect. Okay, so now let us discuss the working of Buckles relay. So during the working of the Buckles relay, so during the incipient fault, gas is generated in the form of small bubbles, and through they pass upward to the relay, and whenever they become trapped in the housing of the relay, the level of the oil that falls. So if I consider this diagram, you can see in this diagram there are how many floats? Two floats provided. Okay, so this one is the upper float. You can see uh, denoted as number 3. Okay, this is not, and the second one is the this is the lower float. Okay, uh, so two floats, upper float and the lower float. So below each float, the mercury switches is provided. That is also shown here, and along with this mercury switch, we have the upper float that is meant for the alarm circuit. Okay, that means to indicate the alarm that some type of minor fault has been occurred. Okay, so operator has to take certain action or decision after the alarm. Okay, so this is connected to the alarm circuit. Okay, on the other side, the lower floor below the lower floor, okay, mercury switch is also provided. Okay, and the lower floor is meant for the tripping of circuit. So whenever the formation of gas or bubbles that is enlarged, then the lower floor comes in the picture. So whereas the formation of the bubble that is very slow, then the upper floor that comes in the upper picture. Now you can see along with this up lower floor, there is another plate known as uh, Baffle Plate that is also connected, and you can see that this bucket relay is connected between the right hand side. You can see the oil is coming from the main tank, and the oil is coming from the main tank. Okay, and on the left hand side, the oil that is going to the conservator tank. Okay, from the main tank, okay, to the conservator tank. Okay, so whenever very small minor fault that occurs in the transformer, then what will happen? Okay, when the fault is occur, so this upper flow, whatever is the thirst provided by the oil, this will no longer remain in the original position, which is there because of the UNC effect. Okay, so the oil level drops because of the formation of the bubble, and bubble are somewhere here. These are the location of the bubble somewhere here. So because of this upper float, balance of the upper float get disturbed, and hence uh, the it actuates the mercury switches just below the upper float, and hence it will issue the alarm circuit. Okay. So this is how the upper float comes in picture, and it issues an alarm whenever any incipient fault occurs. Uh, that is in sub mode, then the lower float comes in picture. Okay, so the oil drop suddenly. So what will happen? Balance of the lower float get disturbed, and below this lower float, we have the mercury switch. So this mercury switch will be actuated, which finally initiate the trip circuit. So this is connected to the trip circuit. So it will initiate the trip circuit. The trip of the trip coil of the circuit breaker is energized, and which in turns isolate the transformer. Okay, so it will isolate the transformer because of the operation of the circuit breaker. So this is how the buckle relay works. Now let us see what are the drawbacks of the buckle relay. So the Okay. So the very first drawback of the buckle relay is the whenever the vibration or the shock are there, maybe because of many reasons like earthquake or maybe some mechanical vibration, then such type of relay may maloperate. So we need some arrangement to avoid such type of maloperation. Okay. So the second disadvantage is the operation of the relay of the Buckles relay, that is the order of the 0.1 second or 100 millisecond, that is considered to be lower compared to the other devices in the transformer. The third type is the application of the Buckles relay that is limited for the protection against incipient fault or non-electrical fault. So this type of relay cannot be used for the protection of the transformer against the electrical fault or internal fault in the winding or the core of transformer. Now, this with this background, we will discuss the second type of fault that occurs inside the transformer, inside the winding of the transformer and the core of the transformer. Okay, so that was all about the buckles relay and the transformer protection. So in the next lecture, we will discuss uh, some other faults that is occurred in the winding and the core of the transformer. Okay. So that was all about that was enough for the today.